Hi, everyone. Thanks for joining us today for our Chronosphere webinar. Today, we'll be diving into 3 keys to faster application troubleshooting. We have a great lineup of Chronosphere presenters, including Julia, our product management lead, Nate, product manager, and John, principal solutions engineer. And now I will pass it over to Julia to kick things off.
Well, thanks everyone for joining us today. I'm Julia Blaze, really excited to have you. Here's a quick overview of what we're going to talk about in this webinar. So first, we're going to talk a little bit about the market landscape and challenges moving to cloud native and working in microservices environments. We spend a lot of time talking to people in this industry about their problems, and we seem to find that they fall into kind of 3 main groups, and wanted to kind of share what we've learned with you all and hear how that resonates with you as well. We're going to end that section with kind of where we see people getting stuck today, which is, as we call it, kind of the dreaded 400-person bridge call. We talk to customers who say they do end up in this kind of situation once or twice a week. Obviously, none of us want to be there, so want to talk through how that comes to be the case. And then we want to move into how you can avoid that. So kind of how we see 3 keys to faster application troubleshooting and really avoiding that bridge call altogether. Once we go through those, we're going to touch briefly on how Chronosphere can help and how the tools we build help address those 3 key components of faster troubleshooting, and we'll give you a quick demo of what that looks like in action. All right, let's go ahead and get started. So first, let's talk about the market landscape and challenges. Today, what we see is companies operating with a ton of really high-scale workflows. And that is high scale both in infrastructure, just like running on a very large set of infrastructure to handle the load. That's high scale in terms of users or customers, right? So if you're facing a large customer base, you've got a lot of individual users. They can all have different experiences with your platform. And that can also be high scale in terms of the data that you're generating. So if you are going through a typical day, you might generate petabytes of data where you used to generate terabytes. And in this new world, what we see people struggling with are 3 kind of categories of problems. So first, poor reliability. You have a system, you are trying to manage this high-scale workload, and it goes down at exactly the wrong time, right? You're an e-commerce retailer, it's Black Friday. All of a sudden, in the middle of Black Friday, you lose insight into what's happening, which can cause lost revenue. The second category of problem is this data explosion. So we see data exploding, like I said, both in volume and in complexity, higher cardinality, higher rates of change, which can be difficult to deal with, even if you do have a system that's very reliable and standing up. If you've got a lot of data in there and you don't know what to do with it, that can be a huge challenge. And also we see things changing and sort of challenges because developers are being asked to fill more of that DevOps role. In the past, those roles were kind of separated, but we hear a lot of people talking about the shift left. Individual developers are being asked to do platform on-call, rotations and monitoring, and are responsible for system health, but it's becoming increasingly hard for them to do that effectively. So why do we think this is happening? Well, we associate a lot of these challenges with the rise and transition to cloud native development. Before cloud native, we often saw companies operating monoliths in local clouds or on-prem, right? Monoliths are predictable, they're slow to change, they're pretty easy to understand, there's a monolith. And in general, they were honestly pretty reliable because of all those factors. But unfortunately, the downsides of monoliths were they were very inflexible. You could only scale up by so much at a time. Scaling up was costly and expensive, scaling down even more so. They were also slow to change, right? Every time you wanted to make a change to a monolith, every test had to pass again. So changes took a long time to plan. You were doing more waterfall development because every time that change took place, it incurred a lot of expense around it just for change management. And they were also really costly to run. So in a world of fluctuating demand, where we're more plugged into customers and we have more dynamic loads on our system, monoliths became very expensive to manage against that load. The market demands flexibility and efficiency, and so in response to that, we see people moving away from that monolith structure and into more cloud native environments. But what that means is instead of seeing 1 or 2 blocks or containers, Now we're looking at cloud native environments, which look like this, right? Just a ton of containers rapidly changing and evolving at all times. What this can also mean is that as you look at this very large picture of a lot of containers, it's kind of hard to grok, right? It's like, how do I know what's important in this picture? How do I know what's working and what's not working? I just have to have a lot of context and information to help me understand that I didn't have to have before. So this is a problem. And I think the first problem we see, like I said, is that problem with reliability. In the past, pretty easy to see whether or not your monolith was healthy. Now you're dealing with containers and auto scaling. So things are spinning up and down all the time. You're also dealing with data in the cloud. So cloud data and cloud providers, possibly multiple clouds, right? And you're trying to manage reliability across all those different systems, which might measure and report things slightly differently to you. And you start to have tooling sprawl. So now I'm not just managing my Kubernetes and or my monolith and my on-prem thing. I have a set of cloud tools for Google. I have a set of cloud tools for AWS. I have a set of DevOps tools. Maybe I have 3 or 4 different sets of DevOps tools, depending on what individual teams decided. So reliability starts to be a real problem when you're running Kubernetes at scale. And what this can lead to, of course, is the desire to collect more data so that you can be more reliable. In the past, let's talk about data a little bit. Your data probably looked like this. Again, you kind of had that monolith. You had a very specific set of data streams coming your way at all times. But as you move towards that containerized world, you want all the data, you want to be able to debug all your system, but you're getting this huge influx of things, right? Just tons and tons of information from all of these sources all at the same time. More data may feel better in the moment because you think if I have more data, I can catch things and I can keep my system reliable, but it comes with so many downsides. First of all, of course, costs skyrocket. I think one of our colleagues was at SRECon this year, and he said that was a huge topic of conversation, is just how are we going to manage costs as they continue to grow exponentially every year that we run in these kinds of environments. And second, the ability of your developers to troubleshoot effectively is negatively impacted, right? And in fact, let's go over to this next slide, because in the past, with that monolith, with that kind of slow to change architecture, developers were craftsmen, right? They kind of sat there, they had a very specific set of things that they owned, they had a very reliable set of data that they were looking at, and sometimes they weren't responsible for DevOps at all. After the code was built, it was handed off to someone else to deploy and monitor. But, and here we come to that dreaded 400-person bridge call. In that Kubernetes world, when you're looking at all these containers, when you're being asked to shift left and take on DevOps responsibilities, when you are also doing all of that, knowing that you're only responsible for 2 microservices and a hugely complex system of maybe hundreds of microservices, you end up in this situation where you know less and less about your system. The data is complex and enormous, and you don't quite know how to parse it or work through it. You end up trying to phone a friend, they phone another friend, and pretty soon 400 people are on every troubleshooting call, and they're not solving it, right? Like no one knows enough to really immediately grasp the extent of the problem and be able to solve the problem. So how do we get out of this mess? We're going to talk a little bit in this flow, and we wanted to sort of ground it as well and kind of a person for us to talk about. So we're going to talk and introduce Asra at this point. And this is really a kind of classic developer who, again, right now you can see in this picture, they're on that 400-person bridge call. They're really upset about this. No one wants to do this. We all want to be building code. How, given this microservices world and given all of these changes, do we manage this? So at this point, Nate, I think I'm going to hand it over to you, and you're going to talk a little bit about what we've learned in terms of kind of keys to success in this new environment.
Thanks, Julia. All right, let's get into it. The first thing we're going to talk about is aligning your priorities. And I like to start this with just a question. Would you rather alert on CPU, memory, network, disk usage of your service, or when your customers are actually having a bad experience? Now, that's a bit of a false dichotomy, but it's probably a little bit of the former, but mostly the latter. So this is what I'm going to be talking about, is that most of you will probably answer that as, I want to get notified when customer experience is suffering. But how do we do that? We know that customer experience needs to be on target. We know the stakes are high, and we know that those moments where we miss a good experience, there's an outage, there's something that's impacting customers consuming our products and services. Those are the moments where they're thinking to themselves, maybe I should go elsewhere. Maybe I should use something else. And those are the things we want to avoid. But it can be tricky to determine, how to know when they're having a bad experience and what we should target as a good experience. So it comes down to understanding what's good enough. What should we aim for? And a lot of the time, your first instinct is, oh, we should be perfect. But turns out that isn't actually the right answer. We'll talk a little bit more about that. And you need to understand, what level of performance your customers expect, what level of reliability we should target for our systems, so that we can kind of navigate that in-between space between perfect and the expectations of our customers. Digging into a little bit about that first instinct of, oh, we need perfect customer experience. I think this is one of the most fascinating things to really understand, really internalize, because 100% reliability is not the answer. And when we lean towards that as our first thing, you really got to understand and kind of compare it to maybe other industries, what it costs in terms of time and effort, and also morale when you start to from a place of targeting that 100% reliability. A couple things to kind of consider. The first is there's some really good research around the cost of every 9 that you add to your reliability. And kind of roughly speaking, each 9 you add in terms of I want to be 99.9% available and these types of things and providing a good experience costs 10x more for your team to achieve. So 10x more in terms of time, effort, cost, all of these things. So when you can start to quickly see that balance of cost to benefit, cost and time, benefit to customers. The more time you spend on reliability, the less time you're spending on building the things that they want as for your product to evolve. There's a common kind of comparison to kind of help folks think about being okay with less than 100%. And it's just this interesting fact about pacemakers. Pacemakers seem like they should be very reliable, 100% reliable, but in fact, they're not. You can look this up on Wikipedia. In 2005, there was this research done, and it turns out that pacemakers are 99.6% reliable. And we as a society are okay with that. And there isn't a huge problem with something so critical having a reliability of 99.6. So this is kind of a commonly used fact, and kind of understand that 100% doesn't need to be the target. And how might you figure out what your target is, and what can you do with that once you understand it? So we'll talk about kind of 2 types of work that are kind of in the balance here. Only working on reliability doesn't seem like the right answer. Your customers won't feel like you're listening to them. Competition can get ahead. These are kind of the 2 things that could happen if you only focused on reliability and were targeting too high of a target. It's also clear that only working on innovation, new features, these types of things, isn't the right answer either. Reliability will suffer if that's the case. So I think there's 2 ways that folks can think about it, depending on kind of how your brain works. It's, I want to, work on just enough reliability to maintain my service level objectives, or I want to work on as much innovation as I can while maintaining my SLOs. I think both of those things can be true. And if you could kind of think about it in either one of those ways that kind of feels natural to you, that's the way to go.
Yeah. And
so
I'm just kind of reminded here of, I often hear people say the most reliable system is the one that has no users. And that's also the system that makes no money.
I love that.
Like, if you keep that in mind when you're building these things, it's like, well, there's always a trade-off, right? Like you have to figure out what works best for your customers for your specific business. Yeah. Because you do want them. You still want them.
Got to get those customers. That's how you're going to stay in business. That's right. Love it. So I think I've convinced you that, less than 100% is the target, but what is it? And then how do you pick the things that your customers care about to measure to ensure that they're getting that good customer experience? There's a couple ways you can go about this. One, and we'll talk a little bit later about some statistics, a lot of people have adopted service level objectives and measuring that customer experience. If you're new to it, that's totally fine. But you can look at competition. You can look at adjacent markets. There's expectations out there that you can draw from to just get you in the ballpark. Even better, talk to your customers, talk to your end users. It is a discussion, right? It is a friendly negotiation, because what you're trying to figure out is, what are you willing to tolerate? In terms of a customer experience, we want it to be good for you at all times. And we also want to not spend all of our time on that reliability so that we can spend more time on innovation and get you the things that you're asking for. Being able to take those feature requests and spend as much time as we can on them and get those into your hands as quickly as possible. So these are kind of two things that I start with. When you start to get those parameters from your customers and you start kind of laying them out, you get that picture of, okay, this could be our first SLO. This is the thing that we are going to react to when there's a problem. And to illustrate this very clearly, what these parameters look like, you can start to think about it. This is actually an SLO that one of our customers is targeting, and it's a pretty common one, right? You've got a few pieces of information here, a few things that you have to decide on. And we'll walk through it so you can get a sense of this is one example of a few that we need to create in order to really monitor that customer experience. It's a percentage. It's a thing that customers care about. It's a threshold that determines what is good and what is bad, and then kind of a window of time. And so you can think of it as kind of Mad Libs-ish, right? You just got to fill in the blanks, and you should do it in conversation with your customers. So in this case, 95% of page loads are under 200 milliseconds for the last 30 days. Latency is a big one. We all are customers of many technologies. I'm sure if you pull out your phone, use any application, that responsiveness is a big deal. So it tends to be one that folks care about. And so what we're saying here is that 95% of the time, things coming back to you that you ask for are going to be under 200 milliseconds. And we're going to do that over kind of a rolling 30-day period. So we can kind of keep track to make sure that that is always the case. And that 5%, the opposite of that 95% is what you can consider our budget. The budget of times, over that time period that we're allowed to miss. And that's okay. And our customers have agreed to that. So when you look at that, we got this five. Yeah.
I wanted to chime in there with one other comment. I think what you're talking about here with being able to work on and define that with customers, it also helps you define it for your organization. And I've at least seen customers have this realization where they start defining good SLOs, especially on latency, which feels so qualitative, right? People can write in and say, hey, your page feels slow. And it's what do you mean feels slow? And that can be really hard to debug and respond to as a developer or on a product team. And I see people over and over starting to really define these. And then the next time a ticket comes in saying checkout felt slow, they can actually verify that. They can go track down that specific customer ID or request, look at how it fit into those parameters and say, maybe it was, but it was one time, please try again. It's totally fine. I'm not going to scram the jets to go fix something. Or, you know what? It was actually 192 milliseconds. So while it might have felt slow, that might just be you. And I don't have to worry about this. I don't have to care. I don't have to wake everyone up to come try to fix something that's not actually happening. That's just kind of in the customer's head. So it's almost it's a great proactive measure, but it's also a great defensive measure that I see people using to help them focus on building new things instead of like a boy who cried wolf, like over responding every time someone says it feels slow. John, I saw you come off mute too. I wonder, yeah.
Yeah. No, yeah, having objective measures for this stuff to ground the team's prioritization is a great call out. Something that was kind of on my mind as we were talking about this, Nate, and sorry if I'm getting ahead of what you were planning on talking about, is like thinking about who your customer is also an interesting conversation to have here because when you have this heavily distributed system with a lot of microservices, teams are probably going to have services that are not directly customer facing. That doesn't mean that this is a bad framework to use. It just means that your customer has a different scope. It's the things that are calling your service, right? Uh, and that's an interesting like thing to make sure you're keeping in mind and understanding is we're not talking about just the front end, but also like individual teams can use this to define the reliability of their services from an internal standpoint too.
That's right. And so I use the term customer pretty loosely, but we all have customers of our service. So it could be internal teams that rely on you as, a microservice to a larger thing that actually does contribute to, something that end users interact with. But yeah, we all have customers, whether it's internal, external, and kind of treating them the same ends up with the healthiest system that is best able to deliver a good customer experience. Awesome. So let's talk a little bit about that 5%. Like we're targeting that 95% of page loads are going to be fast. What is that 5%? What does it look like? How to think about it? Because really that 5% is your budget, and budgets are meant to be spent, right? You don't have to be precious over this. This is the amount of time that you can have some slow page loads, and that's okay. So similar to the cry wolf, like this is going to happen, but this gives us some insulation so that we can focus on that innovation. So generally, one, it's a rolling period. I see 4 weeks, I see 30 days very often, but you think about this rolling budget, and if you have no issues, you kind of get to gain some more budget over time, but then gives you a little bit more to spend. So those are some of the best practices. Think about that kind of 5% as that budget. And then what you do in order to be aware of when you should respond is how quickly am I burning this budget at any given time? So like I said, it's okay to spend the budget, but if I start spending it too quickly, that's when I want to know. And so you'll end up hearing these terms of burn rates. So as my 5% over 30 days starts to dwindle too quickly, that's when I want to react. That's when I know, and I'll get alerts that, hey, if this sustained rate of burning your budget, you're going to run out in 2 hours, 1 hour, even less. And those are the things that you'll set up with your SLOs to be aware of them. All right. Now we've got SLOs. We've targeted some SLIs. We've got whether a 5% error budget that we're reacting to. What can we do with this? So whether you're thinking about it in terms of working on just enough reliability to maintain your SLOs, or working on as much innovation as you can while maintaining your SLOs, both totally valid. Now your service has a clear way to tell you if you're in or out of budget, and that data can help you very clearly, make that argument for focusing on reliability. We are in danger of running out of budget, or we have already. We need to spend time on reliability to maintain that customer trust and keep that customer experience. That pretty much wraps up SLOs as kind of a how-to and best practices, but I did want to spend a little bit of time on some interesting facts about what we're seeing in the industry. These were pulled from our friends over at Noble 9. They have a great SLO report. Just wanted to talk about a few of these really quickly. 80% indicate increase in focus on system reliability. Reliability is in many ways the single most important feature of any system, and we're seeing that in the data and in terms of the initiatives that these companies are focusing on this year and next year. 79 or 69% of companies already have SLOs. So huge amount of the market is already using SLOs. I think that the degree and depth kind of varies quite a bit, but a vast majority of companies, especially those cloud natives, are already using it. Love to see that. 95% indicate SLO adoption is driving better decision making. And that was the last thing we were talking about, being able to see those error budgets and being able to make objective decisions about where you spend your time. And the last two are kind of most interesting. A lot of build it themselves. A lot of people doing this DIY, and that kind of pairs with the last stat of that 97% report that it's difficult to manage SLOs. So over half of the companies that are already using SLOs have built something themselves, and nearly everybody is saying it's hard to manage. So there's some interesting opportunity there to make SLOs even easier to use. So wrapping this up, SLOs wise, there's kind of a few things to kind of take away. SLOs help you become customer centric, helps you know when customers are impacted, and get those kind of high signal alerts to your team so that when they're alerted, they know customers are impacted and they know they need to respond. Fewer false positives. And that decision making. I can appropriately prioritize reliability and performance projects thanks to the data that SLOs provide. All right, moving on. Let's talk about the second thing here, embracing change. We just talked about SLOs, how they are excellent at kind of providing high quality alerts, those high quality signals to let you know when customers are having a problem. But then what do you do when you respond? We've got a couple things here. I think this is probably the most underrated, yet most valuable thing you could do to help your on-call responders. I call it the kind of shortcut to mitigation. And it all starts with this increase in change over the years, right? DevOps, agile software development, it's all about change, constant change to drive improvement, lots of ideally smaller incremental changes with a feedback loop to allow some course correction along the way. And with that increase in change, you can see it in the stats that over 80% of all user impacting incidents are due to change. So with that increase in change, with that statistic, what are some things that we can do to help with that? And, I think of these, anomalies we see in our data. We put ourselves in, our SRE's shoes here, and you see the error rate of a service increase. The data is trying to tell you a story, and the telemetry itself, the metric we're seeing here of this increased error rate is maybe a couple chapters of that story. There's more it's trying to tell you, and being able to bring in some of that change information completely changes how you interpret and kind of like fill in the gaps of that story. So what's missing here, right? Well, if the statistics are right, and you're able to kind of bring in some of that change information, the SRE looking at this error rate could see something a little bit different. And the majority of the time, it could look something like this. It could look like, hey, I see that my service has a high error rate, and I see not too long ago, somebody changed a feature flag related to the service, and the service was deployed. Now the story changes completely, right? For that on-call responder consuming it. Now I've got a metric anomaly and these changes kind of coinciding together. And in a lot of cases, this is the shortcut, right? This is the shortcut to mitigation, and could be the first thing that you look at. Could be a quick rollback or a quick feature flag change to stop the bleeding, stop impacting customers, and kind of preserve those error budgets, right? So what are some of the, interesting properties of how you should think about solving this problem? How do you get this kind of fuller picture story? Well, a number of types of changes out there. So let's talk about some of those key elements. I think the first one's pretty obvious is you need to put all of your changes into one place, ideally. You need to centralize them. And you need to put them with your telemetry data so that they're accessible to everyone as they're consuming it. There's a number of different types of changes. We talked about 2 of them. So being able to categorize them and tell them apart. So whether it's a back-end engineer deploying a service, whether it's a front-end engineer changing a feature flag, or an infrastructure engineer making some changes to Kubernetes or a data store upgrade, being able to quickly tell the difference between them goes a long way in understanding that story. Third piece is kind of organization and relevance, right? So we talk about all these changes happening. Not all changes are relevant to the thing you're looking at. So being able to connect the proper changes to the service that we're looking at, being able to have kind of a service-oriented view that's trying to tell you, here's the state status of that service, and here are the changes that have affected that service recently. So connecting those 2 things together, having a view and high relevance is going to get that actionability.
Yeah, and I think both of us came off mute. But I saw John. Do you want to go first, or should I chime in?
Go for it. Yeah.
Oh, I just, Nate, you mentioned having it all in the same place. And I feel like that sometimes gets lost. People think as long as I'm tracking my change events somewhere, I'll be able to correlate the change with the trend. But the other thing to remember is, right, we're talking cloud native, we're talking Kubernetes, all those things I mentioned earlier. The pace of change is really, really fast. And like each moment you spend trying to pull up another system to like find the change and then have those things side by side is a moment that like the trend changes and all of a sudden you're no longer sure like which change is relevant to which trend. So I just wanted to heavy +1 on having them all in one place, because you can't afford to take the time to go digging through multiple systems to find this, because it's just going to be much harder to find the relevant change if you have to do that.
And just major emphasis on like understanding relevant changes for what's going on in your system. I think about all the times that I've been on call and I get paged. Like the first thing I always looked at was what's broken that I'm getting alerted to, and then what are the things that could have changed that's causing this thing to break. And that was always a mental list in my head, which is fine if the things that you can go and look at, the potential sources of change, are small. But as we talked about earlier, the more complex these systems get, the more moving parts there are, the more potential sources of change there are. And in a dynamic environment that's powered by something like Kubernetes, where you've got pods coming up and down all the time, there's literally constant sources of change that are happening. We don't have to track an event for every pod that spins up, but we do want to eliminate all the other things that are happening so that the things that I have to go and manually investigate as an on-call engineer are as small and bounded as possible, so I can have that mental list in my head and not have an unreasonable number of sources that I have to go and look at.
Love that. Yeah. A great description of that relevance piece, right? I want to focus in on the things that matter, consume those, and then kind of develop my hypothesis from there. Yeah. So wrapping things up on tracking change and using it. Benefits really are less time triaging. We kind of just talked about that. That means more time for doing other things, building value and delivering it to customers. And I think it's a good transition to talk a little bit about what happens when maybe it wasn't a change. What happens when you don't have a shortcut and there wasn't something that kind of immediately helps you mitigate. I was curious, Julia, if you have any thoughts on how we could do that in a repeatable way.
Yes, I do. And it's really interesting to look into this problem and see even when you do have a change, how do you figure out whether or not that's the right thing to go address, or how do you understand whether or not that change is related at all, and what else might be driving the bad behavior in your system. So what I'm going to talk about here is kind of methodologies that we see the really smart people following over and over to help go through this part of it. So to recap, this is kind of what a day in the life looks like for an individual developer who's on call, or like maybe an SRE who's on call. You get an alert, there's a problem in your system. Hopefully it's based on a really well-defined SLO, but you get an alert that maybe you've got 1% of your error budget left. You want to know why this is suddenly a problem. Maybe this is something that woke me up at 4 a.m. when I went to bed at 11, everything was fine. Why is there a problem? And specifically, you're starting to look for what's different that has made things not okay. So you're looking for like those kinds of changes, anything quick and easy, anything clearly associated that you can go ahead and take action on to get things back to normal. So when you have that set of things that you think might have caused the problem, what do? Well, I'm actually going to go back to when you have. Because of the way people have set up their systems today, we kind of see them getting stuck a little bit in this part of the process. They get woken up and all of a sudden they're scrambling to like find the right change or look at the right trend or see the right data. And they kind of call in someone who's really knowledgeable. So we went and talked to a lot of those really knowledgeable people. So you might call them, kind of our heroes at our customer, our experts. I bet you have a name in mind. If I'm like, who are you going to call? You probably say, oh, it's Ryan. Like, it's definitely Ryan. I always call Ryan when I can't figure out what goes wrong. So this is what the Ryans of the world do in this scenario. They start to build a hypothesis, and it might be based on a change event they saw somewhere else. It might be based on a change event that seems really clearly correlated. It might be based on like some deep secret magical food knowledge they have about what tends to happen every Monday morning at 9 p.m. or whatever it is. And they form these hypotheses, and then they go about proving and disproving them. And what they see is that this is what helps them get to the root cause of problems faster. They're not actually experts sitting there going, oh, I know exactly what happened. But they're experts in going there and saying, I know exactly how to get to the answer. I have a process for getting to the answer, and that process is repeatable. And it really doesn't matter what the data looks like underneath. I can follow the process and I'll get to the answer quickly. And I think that was a really important thing for us to hear and then talk about internally, is like, how do we make that process something that repeats? Because yeah, the data always changes, the system always changes. The only constant thing is that there are a lot of changes, like Nate just said. So we can't like guarantee that the data is going to look exactly the same, but we can give you a really good process for triaging those changes and figuring out what's happening. We can kind of take that deep foo of the expert SRE and codify it so that anyone can follow it. I will say also today, when we talk to people following these processes for understanding or proving, disproving that a change had caused a problem, it takes a long time. So as we get into this, we wanted to understand what the steps were, but we saw people following these steps using like really custom built tools. They might have several query languages. They might have a bunch of like Google spreadsheets with VLOOKUPs where they put data to try and correlate it, right? Like they might have scripted things that they run over their data. So we do see people like getting pretty in the weeds with the different tools that they have to try to codify these processes. But again, just to reemphasize, the process was almost always the same. It was something that had some really specific steps to follow. And in fact, as we look at those steps, I can tell you what they are right here. So this was pretty much it, right? As we talk to the people who do really well in these environments, they always start with asking what happened. Was there a system change, like a deploy? Was there an observability change, like maybe I added a new label or a bunch of new values for a label in my system? Was there a data or workload change? Did I onboard a new region? Did a bunch of people start coming in from a new cluster, that I hadn't been seeing a lot of traffic in before? So was there an actual workload or data change underneath my system? And then they take the thing that changed, or maybe the set of things. So like John, you were like, I want to reduce the surface area of things that I investigate. So now maybe I only have 3. So they take those 3 things that are the hypotheses. It's one of these 3. And for each of them, they start to do comparisons. So they look at the things that were erroring and the things that were successful, things that were slow and things that were fast, things now where the bad behavior is versus things earlier when like everything was calm and my error budget was fine. And they start comparing and they start to see if that change is common in one category or the other. So is that feature flag always in the errors and always in the slow things or not? Sometimes it actually can be easier to disprove, like, oh, that feature flag is in both errors versus successes. Great, that's not actually the cause of my change. Let me go back to the deploy, right? And let me do the same thing with the deploy. Oh, when I do it for the deploy, I actually see something else. I see that there's that region that's actually different between those. Now I have a new thesis. My thesis is it's about the region. Now I can go do the same thing and I see, okay, that region is definitely associated with things that are slow, right? So they kind of take this hypothesis, they run these comparisons, see if it's common or not. and work to prove it or disprove it. And they're looking for outliers, right? They just want to have confidence. They want to see that something is an outlier and things that look bad so that they have confidence that they can go and change that thing and that changing that thing will address the problem. So hypothesis-based troubleshooting. We actually went then and we started to look in other industries to see where else this might be common. And the other place we found this kind of process is in the medical industry, right? And you have doctors, and I don't want to say being a doctor is like being a software developer. Obviously, they are very different professions, but you have some similar challenges, which is you've got a lot of symptoms. Human bodies are very complex. Kubernetes systems are very complex. You've got a lot of symptoms. They're changing all the time. They're evolving. They're reacting to things in their environment. And you have to, but you know something is wrong, right? Like you have a stomach ache. The system has a lower error budget. Maybe I'm stretching this metaphor a little bit. That's okay. But the point is, you want to use the same workflow to be able to kind of tackle and quickly get to a probable cause, right? Like a probable outcome so that you can fix it faster. And so we really thought that was interesting to kind of look at that medical process and experience and actually see if we can look at what they were doing and maybe take this approach with software development. So the metaphor maybe is a bit of a stretch, but is the approach a stretch? And we think not. We actually think this is a really productive way to think about triaging problems in your system. It's a systematic approach. So it's something that you can kind of codify, you can document, people can repeat over and over. It services insights from your existing complex data. So it actually takes that complexity as a benefit. It's not like I have to reduce complexity to find the source of the problem. I actually can lean into complexity and say, hey, I just know how to like triage and get through that complexity. And so that complexity actually now becomes a benefit. Maybe I even want to increase complexity so that I can get more fine-grained information about what's an outlier. So we really liked that it was a process that leaned into the complexity of modern software. And it does help you find the answers and end the bridge call faster. You know, we talk about lowering mean time to sleep or mean time to return to sleep, but it's so much easier to like process through some complex data, a lot of different hypotheses, change events, workload events, and get back to sleep if you have something that's repeatable and systematic. And we really think that thinking of this as a true workflow that you need to make repeatable is a really helpful way to kind of finish that process, find the problem, reverse the problem, whatever it is, maybe take that cloud region back offline or divert that feature flag and get back to sleep. And that's ultimately everyone's goal, right? We don't want to be up at 4 a.m. We don't want to be fixing things. We want to get back to sleep so we can wake up, have our coffee, and go back to writing awesome code that makes our company money.
And
Yeah.
Julia, you said it earlier, like when we were talking to senior engineers, this is effectively the process that they were doing to help resolve incidents when they're getting escalated to. It sounds like the hardest part of this for most people is just again, like the complexity of the systems and the volume of data and the number of potential hypotheses that you can have that you have to go and know where to go in order to prove or disprove each one, right?
Yeah, totally. It really like that piece, this like existing complex data, existing complex system, is a huge component of it. Like even if you have put those events in the same place, right? And you've correlated them with services and you think they're here, there's so much information around those events. Sometimes you see multiple deploys because there's a platform deploy, so like a bunch of things went out that might have touched your system. Feature flags changed at the same time as the deploy. So like, is it that interaction that's causing the problem? There's just like endless places that you can use to build new hypotheses. And the important thing is to kind of triage those and move through them very quickly. Not get the right one. I would say almost like if you say, hey, my system identified an anomaly, the thing we see people doing is saying, as soon as they see the anomaly, they're like, really? Like, is that really the anomaly? Is that really a problem? Like, how do you know? How do I know? Right? Like, no matter what you do to try to pinpoint the problem, it's hard. It's just a complicated system. And so you have to have a way to process whether or not that thing is a problem, the problem, and then what caused the problem very quickly.
Yeah, definitely.
All right. And I think actually, John, I'm handing it over here to you.
Yeah.
I hope this has been helpful so far, but I'm excited for you to talk about maybe how we can help.
Okay. Yeah, let's dive into it and talk about how Chronosphere can help with these things that we just went through and reviewed. And actually, before I get into maybe the specifics here at a high level for anyone who's new to Chronosphere and isn't familiar with our offering. We actually have two products that we provide to our customers. So there is our observability platform, which is where I'm going to be spending most of my time talking about. We do also provide a full-featured telemetry pipeline for routing observability data or telemetry data in general to various destinations, doing optimization, enrichment, and transformations along the way as well. With the observability platform itself, a few different things I'll call out here really quickly. From a data collection standpoint, we do provide compatibility with all of the most common open source standards across metrics, traces, logs, general telemetry data, as well as providing support for a handful of proprietary standards as well that are popular across the industry. For data coming into Chronosphere, we provide a lot of tooling and analysis to help people understand what information is actually being used in practice, what's actually valuable to help them understand their systems during incidents based on their actual usage, the dashboards and alerts that they define, as well as giving them flexible, expressive tools to refine that data. So they only have to pay to persist the information that's actually helpful to them in practice. So our customers are able to significantly optimize and reduce the amount of data that is getting paid for and stored in the system and being used and sifted through for incident analysis by significant amounts, 60% or more in a lot of cases. And then, of course, making the data available in a highly scalable data store that can be leveraged by different members across teams to understand what's going on with various aspects of the system. And in front of the user interface itself, we have this discovery framework that we refer to as Lens to help make sense of the information that we are seeing stored in the platform, identify what services it belongs to, and surface KPIs for each of those services to relevant service owners in a consistent fashion so that when you are on call and you have to look at an issue, you're able to navigate across the system, even if it's not something that you own and are responsible for, and get a quick understanding of what's going on with it and where to go and take your investigation when you're going and proving and disproving those various hypotheses. So there's a few things that we want to kind of go layer deeper on that are specifically relevant to these key components we've been talking about throughout the webinar. The first being Chronosphere Lens that I just mentioned. This is, as I said, a discovery framework that we have built out to help put all the relevant telemetry data across different data sources, whether it's open source or proprietary telemetry data, integrate it and centralize it around the services that you are owning, maintaining, operating, and developing on. So you have a clearly identifiable mental understanding of what's going on in the system that aligns to how you might think about things yourself as a service owner, and provide all the relevant contextual information for each service to help you understand what's going on with it during an investigation. And that includes things like what has changed with this service recently. So when you are getting alerted that you are burning through your error budget for a service, you can go and take a look at that service in Lens and see if there's been a deployment or a feature flag or any other type of relevant changes that are happening in the system that would impact its behavior aligning to the way that you're seeing with your SLOs. And when that happens, we can go and further analyze the information if we need to develop hypotheses about what could be going on. And prove to ourselves that a deployment is the cause of the issue or is not, in which case we can look elsewhere. Nate, I don't know if there's anything in particular that I've left out that you want to add here.
I was actually thinking about something, John, as you mentioned this, which is it almost seems oversimplified to say, hey, be able to see a service and all the related things. But like having that in one click too, without having to write a query to retrieve all that information or go to all those different systems. Like we kind of touched on this earlier.
Yeah.
I don't care. You can have a ton of tabs. I know I have crazy tabs all the time. You just lose a little context every time you switch and have to like look at something new or learn to write from QL or log QL or trace QL to like pull back that information. So I think it's been really powerful to see how much having it in one page with one click without actually need to write a query has made this more accessible and more helpful for people.
Yeah, absolutely. It's a great call out. A big part of what's being done here is avoiding the need to manually curate the information. Anyone can build a dashboard to put relevant information together, but it's a different matter to know how to access that information as well as understanding what's relevant. Being able to do it kind of in an automatic fashion is a huge value add, I think, for our customers.
And the only thing I'd add is kind of adding on to the relevance statement there is sometimes, your change wasn't the problem. Sometimes you didn't make a change, but we have these dependent systems and, one of your upstream or downstream, dependent services did make a change. Being able to find that out, even though you don't own that service, can be challenging, but when you can do that quickly, can be a very effective way at understanding kind of the state of your system over the last few hours and give you some hints on where to investigate, even though your system's having a problem, but you didn't change anything.
Yeah, absolutely. And we kind of alluded to this, but when you do have a change or a hypothesis that you want to go and investigate and prove or disprove, we've built our own dedicated capabilities to help with this hypothesis-driven troubleshooting that Julie, you were talking about before. So we actually call this differential diagnosis. No need to mince words. This is based on distributed tracing data, being able to take advantage of the context-aware traces within your interdependent cloud-native environments to analyze for a given component in the system what is happening that's corresponding to successful requests, failing requests, fast requests, slow requests, and how has it changed compared to a historical point in time. So when you are seeing that there's a increase in errors that's causing you to burn through your error budget, and you think that it's related to the billing services I have in my screenshot, we can go and take a look at what about requests to the billing service, all the relevant information in traces uh, around this point in the system that we're analyzing, what is corresponding to increases in errors that we might want to go and anchor around in our investigation. So being able to very quickly do that with all the relevant information and not, again, as you mentioned, Julia, have to write complex queries or have to manually sift through a bunch of information or know where to go in the system in order to find the right information allows you to much more quickly get through proving or disproving various hypotheses in this hypothesis-driven troubleshooting cycle. So being able to make it easy and accessible and fast as well, so that when you do have an issue, you're not spending a bunch of time coming up with ideas and then having to figure out where to look in order to find out whether or not that idea was the right answer or if it's just another disproven hypothesis in the pile of things that we've gone and looked at.
And yeah, the only thing I might chime in on there is all of those things, plus it has to work at scale, right? And we did design this to kind of work on the kind of high scale data that your system generates. Because if you have to, in order to like manage costs, if you have to really cut down on your available data or whatever the reason, if you only have 100 spans here instead of 135,000 plus 123,000 spans from the screenshot, like if you've only got 100, you're just going to be a lot less confident. So it's all about like making it fast and also doing it at scale so you can be confident in the results that it shows you at the end of the day.
Yeah, absolutely. And a lot of our customers that we work with that leverage this have huge amounts of data that they're capturing from their systems. They're able to better manage it using the control capabilities I briefly talked about. So they're able to ensure that the data they are capturing is relevant, and then using tools like differential diagnosis to be able to churn through that data efficiently when they need to figure out what's going on in their systems.
Yeah, those things really go hand in hand. You brought it up, and gosh, I should talk about this more too, but it's like you want it to work on high scale data and you want all the high scale data to be valuable data. You don't want it to be a bunch of junk. You want to like get rid of the junk using something like, control plane capabilities so that now you're looking at a large amount of highly valuable relevant data to get good results back out.
Yeah, absolutely. Oh, I forgot my click through. Oh no. Yeah, you can see kind of the different elements in here. We can identify the tags that are going to be most likely associated with the hypotheses that we want to be able to test so that you can come in here and get quick results. Do historical comparisons. So when you're looking at something that has started becoming a problem, we can compare what did it look like when it was healthy versus what does it look like now, and not have to switch back and forth across tabs or anything like that. And quickly rank and surface the things that are most likely to correspond to the bad behavior that we're trying to troubleshoot right to the top with intelligent ranking of the results. And last but certainly not least, we are also working on building out better SLO management for organizations that are adopting service level objectives. So this is something that is coming soon, not totally released on the platform yet, but it is designed as an extension of the Lens discovery framework. So for Chronosphere customers that have their individual service views, they'll be able to very easily take advantage of SLOs, define them for their services based on the relevant telemetry that we've discovered without having to, again, write complex queries or have to worry about the fairly intricate math that goes into defining these burn rate alerts for successful SLO-based alerting within your system. So this will make it a lot easier for people to get started with SLOs. All you need is an objective and an area of the system that you want to be able to measure it against. And also make it a lot easier to manage by having it built directly into the platform and available to use with all of our kind of standard capabilities for managing configuration within Chronosphere using things like Terraform or any of their configuration management tools. So this will be coming early next year, spring 2025, but it is something that we can show a preview for you today, excuse me. And with that said, why don't we jump into a demo of the platform and we can walk through what it looks like combining these different tools in practice for that efficient troubleshooting experience we've been talking about throughout the webinar today. All right, so let's dive into an example of how you can use SLOs, Lens with all of our context in one place and differential diagnosis together to kind of really bring to life this experience that we've been talking about, the different troubleshooting techniques that we've been evangelizing on our webinar today. So you can see here, I'm looking at a SLO within Chronosphere. So this is part of our preview functionality. And in this case, I'm looking at checkout order availability. So I want to know if users of my web store are able to successfully check out and confirm orders within their site. I've got a defined objective. We can see the recent availability and our error budget remaining. And I can also see how availability has changed over time. You can see here that in the window I'm looking at, there's been a pretty significant drop off in the availability for my checkout orders request. This is the type of thing that will trigger a service level objectives burn rate alert. And so if you look in the top left-hand corner, you can see we've got a little red exclamation point. That means we're in a critical status. We're burning through our error budget way too fast. And if I don't fix this, then we're going to violate our service level objective for this SLO here. In addition to that, we've got a few different relevant changes that we're watching for within the system. You can see, for example, deploys are one. Also, looking at the chart here, there was a recent feature flag change that happened for the service that this SLO is associated with. I can go and click in, view details, see what's going on here. Looks like my ordering service has had a feature flag change to enable support for American Express cards. That's an interesting thing that could definitely impact checkout availability, although it looks like it took a little while before we started seeing any drop off in availability. So I don't know that this is something that is directly causing the issue. It doesn't seem like it lines up well enough for me to go ahead and say, this is definitely the cause. We want to go and validate that as a potential hypothesis as we're going through and looking at the system. So there's a few other details that are available on the SLO's page, such as being able to look at the underlying key metrics that are powering it. So in this case, RPC metrics for requests per second, errors in the system, and latency as well, all in one place. You can see the increase in errors that we saw in production, much in line with the chart above that we saw looking at our availability. None of this is a clear smoking gun, though, so we want to be able to get a little bit more information about our ordering service and the checkout endpoint that we're looking at here. I can do that very easily. Just going to go ahead and click on the owning service here on the right-hand side. And we'll dive into the main service view within our Lens framework for the ordering service. So this is going to give me some of the same information I had before, namely those RPC requests, as well as the relevant changes, that feature flag that we saw earlier. We're also layering in a different additional information that has been discovered by Lens or the ordering service. So compute metrics, letting me know what CPU utilization, memory usage, network throughput for my ordering service looks like over time. I can also scroll down a little bit and see where it fits into my system, the dependency map of the service itself, all the things that it talks to, all the things that talk to it, so I can get a sense of what might be affected or what might be affecting my ordering service during my investigation. If I scroll back up really quickly, again, there's nothing that kind of screams to me that there's a problem here with the ordering service itself. Compute looks pretty steady during the time period where errors went up. I still see that feature flag. It's something that's kind of nagging in the back of my head, but it doesn't look like it's a clear smoking gun. And so I want to look at dependencies and see, is there anything else that's seeing errors that might be corresponding to the issue that I'm seeing here? There's a few things that are showing up here. So my notification service has an increase in errors, up 15%, which does feel like it could be a lot. Let's check the billing service as well. Okay, 3,000% increase in errors for the billing service. I think we found that the issue that we're looking at is actually coming from the downstream service here, or at least if I'm looking at this, I'm going to start by looking at what's going on with the billing service, because a 3,000% increase in errors is a little silly, to be honest. From here, I want to be able to understand what's going on with the request to my billing service that is causing this big increase in errors. There's two different things that I can do here. I can go and just generally explore the underlying trace data for the service that's powering this dependency map. In my case, I want to go and analyze all the requests for the billing service and understand what might be corresponding with that error behavior. And so I'm going to use differential diagnosis to do that. If I click in here, it's going to take me to Chronosphere's Trace Explorer and drop me directly into the differential diagnosis view. This is going to analyze all of the spans for the billing service that we're looking at here in the time frame that I've got selected. You'll notice as I'm going through this, by the way, that the time frame that I've got is, of course, staying consistent as I navigate across the platform. Same thing with the change events that I saw on this SLOs page. It's following my investigation as well, so I can see when that feature flag was being deployed as I navigate through the system. I also am going to have some analysis, excuse me, for a handful of different tags that have been, likely associated with different issues and investigations in the past. These are likely good sources for me to develop hypotheses on top of about what's going on with the service I'm looking at. And from here, what I want to do is focus on errors. So I'm going to change my ranking of the information here across errors, successes, P50, P99 duration to orient all the information here around error spans in particular. I can use this as kind of an initial assessment of what's going on in the system. A couple of things that stand out to me: the build version for the billing service, as well as card brand equals Amex, seem to be the largest corresponding sources of errors. If I compare that over to the successes, you can see that there's a very small portion of successful requests that have card brand Amex versus the 97% almost failure rate that we're seeing for the failing requests here. So that seems like something that could be relevant, and it is in line with the feature flag change that we saw originally. So my hypothesis of, hey, maybe something's wrong with Amex requests could be valid. Although the fact that we have some successful requests is kind of interesting. It suggests that it's not an outright issue. I want to know how this is looking compared to historical behavior. So we can compare against the past and see that, okay, it looks like there was a period of time where my failure rate for American Express cards was actually relatively low, and it jumped up and became a lot higher. So something has changed recently that's caused a shift in behavior here. Seems like more than just the feature flag is causing an issue with American Express card orders here. And I want to understand when exactly this jump took place. I'm going to guess aligning with where we saw our drop in availability, but I want to prove that to myself. That's my hypothesis I want to take a closer look at. My next step here, I'm going to orient on card brand specifically and view it over time so we can see exactly what's going on here. And yeah, we can see at around 1120 is when we saw a big increase in failures for card brand equals Amex. You can see my feature flag change that we saw originally was around 1115. So about a 5-minute gap of things going well before everything started to fail. And funny enough, there's another event that we're seeing from our trace analysis that is aligning up almost exactly with this increase in errors. So let's take a look at this, this change to see what was going on at this point. Aha. So if I look at this, the billing service just finished deployment right around 1120, almost exactly lining up with when I start seeing the increase in errors for American Express cards. This makes me think pretty positively that the change here that was deployed is likely the cause of my issue. So something about the billing service itself is causing my American Express card request to fail. This gives me a pretty easy thing to go and prove or disprove in the system. And in order to do that, I'm just going to go ahead and zero in on American Express card requests here and grab an example trace from the system to take a look at what's going on when these requests fail. So this is going to drop me into a trace waterfall, and I can go and look at the billing service in particular at the bottom here and take a look at the context for it. I see this 400 bad requests that's showing up for my American Express card brand charge in the billing service. So something about this deployment appears to have caused support for American Express cards to stop working. Likely a regression, something where the team that was testing deploy didn't test the new feature flag that just got rolled out beforehand. And so we've got a bad interaction between these two changes that's causing the problem. My next step, if I'm investigating this issue, is for me to roll back this deploy and probably send the link to this request to the team that owns the billing service. They can take a closer look outside of the investigation as a follow-up. But walking through this process and kind of taking a step back here, we were able to start with an actionable alert that something is going on impacting issues when it came to the SLO on checkout order availability. From there, we can track it into the service that SLO is associated with, identify that the issue is not associated with that service specifically, but one of its dependencies, and then dive into the dependency where we saw issues coming from and quickly get to the bottom of what things are most likely associated with these failures by using differential diagnosis and change event context to help inform hypotheses about what's going on and the information that we're seeing from the system. All of this together is mirroring the techniques that we've been talking about throughout the webinar here. So being able to have actionable alerts about your system that are clearly aligned to customer behavior, being able to understand what changes are happening that are relevant in the system, and embracing the idea that changes are happening constantly as a foundation for hypothesis-driven troubleshooting. The potential changes that we're seeing or the things that we want to be able to prove or disprove as hypotheses in the system, or the behaviors that we're seeing in our data as we analyze it, can be the basis for hypotheses as well. Hopefully the demonstration here can really bring to life the techniques that we're talking about and make it feel real for y'all. If you're interested in seeing what this looks like in more detail, please do reach out to us afterwards, and we're happy to do a more in-depth demonstration as well and give you a sense of how Chronosphere specifically can help with your troubleshooting challenges.